Now we're going to focus on our solar system, specifically the sun. Our sun is the central body, the star, in which Earth and all the other planets revolve around and orbit around in our solar system. Now our sun is a normal G2 star. Its chemical composition include hydrogen and helium. So hydrogen and helium are the main two elements. Hydrogen being 92%, that's going to be the majority of the elements consisting of stars, specifically our sun. For our Earth to be at the right spot in the distance to the sun as the sun produces its own light, it is the perfect place, and it really shows God's design here. If it was too close, as we're going to be talking about Mercury and Venus, it's going to be too hot. If it's too far away, like Mars, it's going to be definitely too cold. As we move into some of the gas planets or even the ice planets, it's going to be way too cold. As I just said, hydrogen and helium are the main gaseous elements that compose the sun. And as I said, the Earth and other planets orbit or revolves around the sun. The sun also rotates or spins, and we'll be talking about how that is actually going to be very different or even the opposite of how the Earth spins. In correlation, how large the sun is compared to the planets, it shows that Earth is extremely tiny to the size of the sun. Now we have these structures. You're going to have to label and identify these parts. We're going to go through, I'm going to show you a list, and you're going to have to write them down. I would encourage you to do index cards for these terms, but basically we're going to start with the corona, and we're going to work our way into the core of the sun. Okay, I'm going to give you a couple minutes to go ahead and write down the terms, the definition of the terms. We're going to start with the corona, which is specifically the bright light or the glow coming off of the sun. When we have a total eclipse, and we'll be talking about what that is in just a little bit, that is what we're going to actually see. The corona is the glow around the sun. Then we move more interior. This is going to be the chromosphere. This is the reddish gaseous layer that's basically right above the photosphere. And basically, this is going to be chromo, referring to color. This is going to be the red, orangey color that we're going to be seeing from the sun. And this makes the star's outer atmosphere. The photosphere is the bright and shining envelope or covering of the star. This is where light, since photo refers to light, this is where light and heat will radiate out of the sun. This is below the chromosphere. Then we have the convection zone. The convection zone is basically the area where you have convection occurring, the rising and sinking of heat in the sun. Then we have the radiation zone. The radiation zone is where energy is going to be given off. This is where energy is going to be transported out from the core. Then we have the core, which is the center. Now, seasons occur based on the tilt of the Earth. As the Earth is tilted on the axis, the sun's rays hit the part of the Earth, and that's going to give us a season. So if the Earth is tilted towards the sun, specifically the northern hemisphere, that's going to give the northern hemisphere the summer. And as the northern hemisphere is tilted away from the sun, that's going to give us summer and winter solstice. Now, this is pretty interesting. As we know, for the Earth, as the Earth spins, the poles are going to be smaller, spinning faster. The equator of the Earth should be spinning slower because it's wider, it's larger. But in the sun, this is going to be the complete opposite, where the poles actually spin, and it takes longer for the poles to spin than the equator. The equator actually spins faster of the sun than the poles. This is actually called differential rotation, where the equator spins faster than the poles. This is more of an opposite. This actually can create sunspots and different solar activities in the sun because of this differential rotation. Here we have a false color image showing a theoretical model of basically how hot and cold the sun is because of the differential rotation, basically showing that perhaps the sun could be colder in the core. Now, focusing on the sun's magnetic field, the sun's corona, that glow, is basically threaded with different networks of magnetic fields, and this is going to create your solar storms and your solar flares because of this magnetic field. When the sun's magnetic fields are filled with hot gas, we're going to see a magnetic loop, as seen here. And this is going to be with your solar flares. Now, sunspots appear darker, but actually they're a drop in temperature. They're actually a lot colder. These dark spots on the surface of the sun actually drop in temperature, and these are going to be in the photosphere. As we can see here in this graph, we estimate that the photosphere is actually colder, and then we're getting warmer out to the corona. It's going to be actually hotter than what it is more to the core. As we were talking about with solar flares, we talked about the magnetic loops, solar prominences. A prominence is basically a dark cloud of material suspended from the surface of the sun. These loops, which we said if it's filled with gas, it's going to create that magnetic loop. And these prominences, these magnetic loops, these solar flares can actually remain, okay, for days or weeks. So solar flares are basically explosions on the surface of the sun in the photosphere, and basically they can happen in a matter of minutes. They're going to release an extreme amount of heat, and they do occur near sunspots. Here we have the corona, which we said is this glow around the sun, so it's not technically a layer, but the sun's corona, we said, can be seen during a solar eclipse, and it's believed that it is forever expanding, and this is going to lead to solar winds. Now, what are solar winds? This is a continuous flow of particles, ions, electrons, neutrons, that's released from the sun. And these solar winds consist of slow and fast components. So a solar eclipse is basically where the moon is going to block the sun's light. Now, you will need to know what is the Umbra and Penumbra. We're going to do a lab on this that you will need to be aware of. Now, the Umbra is the full shadow or the specific shadow, while the Penumbra is a partial shadow. Now, if you remember in 2017, we had a solar eclipse passing over South Carolina, and many people from North Carolina drove down to actually see the total solar eclipse.